alpha t, I is equals to I naught plus alpha t, where I naught is equals to 10 amperes, alpha is equals to 4 ampere per second. Find the charge that crossed through a cross section of the wire in 10 seconds. Find the charge that crossed through the cross section in 10 seconds. Find out that. How much? No? Check properly. Check that properly. Huh? 15? No? 30? 40? Why you are getting different answers, sir? Do integration only. 300 is the correct answer. ಮತ್ತೆ ಏನು ಡೈರೆಕ್ಟ್ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದೆಯಾ ಎಲ್ಲ 500 no 300 is the correct answer. Basic integration only. What is there in that? Nothing is there. Integration of t ಅಂದರೆ t square divided by 2 ಬರುತ್ತೆ ಅಮ್ಮ. ತಗೋರಿ ಓನ್ಲಿ t square ತಗೋಬಾರ್ದು. ಏನು ಸಾನ ಓನ್ಲಿ t square ತಗೊಂಡಿದ್ದೋ ನಿನ್ನ ಥರ. $300 is the correct answer. First of all, write I formula. What is I? I basic formula. Hello. Write I basic formula. dq by dt. ಹೌದಾ ಅಲ್ಲಿಂದ dq ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು. dq is equals to I into dt. ಇವಾಗ ಇಂಟಿಗ್ರೇಷನ್ ಮಾಡು. ಐ ಫಂಕ್ಷನ್ ಕೊಟ್ಟಿದ್ದೀನಿ ಆಲ್ರೆಡಿ ನಾನು, ಹೌದಾ? ಅದಕ್ಕೆ ಇಂಟಿಗ್ರೇಷನ್ ಮಾಡಬೇಕು ನೀವು, ಆವಾಗ ಕ್ಯೂ ಬರುತ್ತೆ ನಿಮಗೆ. ಟೇಕ್ ಬೇಸಿಕ್ ಫಾರ್ಮುಲಾ ಆಫ್ ಐ. ಆನ್ಸರ್ ಈಸ್ 300 coulombs. ಎಸ್. ಸೊ ಹಿಯರ್ ಐ ಈಸ್ ಈಕ್ವಲ್ಸ್ ಟು, ವಾಟ್ ಇಸ್ ದ ಫಾರ್ಮುಲಾ ಫಾರ್ ಅಸ್? ಬೇಸಿಕ್ ಫಾರ್ಮುಲಾ ಐ ಈಸ್ ಈಕ್ವಲ್ಸ್ ಟು ಡಿ ಕ್ಯೂ ಬೈ ಡಿ ಟಿ. ದೆನ್ ಡಿ ಕ್ಯೂ ಈಸ್ ಈಕ್ವಲ್ಸ್ ಟು ವಾಟ್ ಐ ಕ್ಯಾನ್ ರೈಟ್? ಐ ಇಂಟು ಡಿ ಟಿ. Now I want to find out the charge, so that q is equals to integration of I into dt. Integral I value is how much I have given? I naught plus alpha t into dt. Don't substitute the values now, only later on we can substitute. Now whenever you do the integration of I naught into dt will be how much? I naught t. Integral dt is how much? T only, right? Then plus alpha is constant. What will you get here? T square by 2. That is what we will get. Now you just substitute the values of I naught and all. I naught is 10, and then time is how much I have given, that as 10 seconds, plus alpha into alpha is how much I have given? 4 ampere per second, and then t square is 100 by 2. Then this will be 50, and then this is 100, and then 200. Total answer is how much? 300 coulombs. That's the answer. And why you people got 500, 30, 40? ಏನೇನೋ ಹೇಳ್ತೀರ ಆನ್ಸರ್ಸು. ಟಿ ಸ್ಕ್ವೇರ್ ಬೈ 2 ಮಾಡಬೇಕು. ಇಂಟಿಗ್ರೇಷನ್ ಆಫ್ ಟಿ ಚಿಕ್ಕ ಮಕ್ಕಳು ಕೇಳ್ರಿ. ಇಂಟಿಗ್ರೇಷನ್ ಆಫ್ ಟಿ ಪವರ್ ಎನ್ ಡಿ ಟಿ ಈಸ್ ಈಕ್ವಲ್ಸ್ ಟು ಟಿ ಪವರ್ ಎನ್ ಪ್ಲಸ್ 1 ಬೈ ಎನ್ ಪ್ಲಸ್ 1. ಕೇಳಿದ್ರಾ? ಟಿ ಪವರ್ 1 ಪ್ಲಸ್ 1 ಬೈ 1 ಪ್ಲಸ್ 1 ಏನು ಬರುತ್ತೆ? ಟಿ ಪವರ್ 2 ಡಿವೈಡೆಡ್ ಬೈ 2 ಬರುತ್ತೆ. ಫಿನಿಶ್ಡ್? ಹೌ ಮೆನಿ ಹ್ಯಾವ್ ಯು ಗಾಟ್ ಕರೆಕ್ಟ್ಲಿ? Very less. See, I know the truth here. Remaining people don't know the integration. Correct? I will explain that separately in the classes. Okay. The current density at a point. J is equals to 2 into 10 power 4 J cap, 2 into 10 power 4 J cap ampere per meter square. Find the rate of charge flow. Through a cross section S bar is equals to 2I cap plus 3J cap. 2I cap plus 3J cap. You have to find out the rate of charge flow. I'm sorry. What is the rate of charge flow means? I only, current only. How much? 6 into 10 power 3 na? 6 amperes is the correct answer. Only 6 is the correct answer. Check the units, sir. Check units properly. 6 amperes is the correct answer there. Directly you will get what product you have to take? Dot product between J and A. I shown you already yesterday. J is equals to, what is the formula for us? J is equals to I divided by A. Then I is equals to what will get here? J dot A. J bar dot A bar. Now this J will take as, what is the J value they have given? 2 into 10 power 4. Only J cap given. And then dot product. A bar is equals to how much will get here? What is the area here? 2I plus 3J. 2I plus 3J, but also they have given us how much? Centimeter square. You have to convert into meter square. To convert into meter square, what you have to take? 10 power minus 4. Now, dot product nothing but what you have to do? I dot I, J dot J you have to do. I value is how much here in this? 0. So that there is no need to take I value only. Then only J value you have to take. Always the dot product nothing but you have to multiply the like vectors only, that is either II or JJ like that. So that I dot I you have to do plus J dot J plus K dot K like that you have to do. So here I dot I am doing here. ಏನು problem ఏంటి? చూపియాలా మొబైల్? మరి దొంగలాగా ఎందుకు ఇలా అంటావు? So here 2 into 10 power 4 J cap is there. Here I cap and then J cap is there. Now always you have to multiply the like vector in the case of dot product. In the case of cross product, what you have to take? Unlike vectors. I cross J is equals to how much? K. J cross K is equals to how much? I. And then K cross I is equals to J. I have shown you already circle method. Yes sir, in the circle method we can go either in clockwise otherwise anti-clockwise like that. Now the dot product nothing but you have to do only for the like vectors, that is I dot I plus J dot J plus K dot K like that you have to do. Now here in this I value becomes how much? 0. Nothing is there means 0 I cap is there. 0 I cap and then 2 into 10 power 4 J cap and then 2 I cap plus 3 J cap like that it is here. Now you have to multiply I with I. I value is how much here? 0 into 2 becomes how much? 0. Then J value. J is how much here? 2 into 10 power 4 into 3. How much it will be? 6. 6 into, this is 10 power plus 4, this is 10 power minus 4. How much it will become as? Just 6 amperes only. That's it. This is the I value, current. Clear? Just dot product only. He is seeing his photo in the mobile. మరి నీకెందుకురా ఫోన్తో? ಉದಯ್ ತೋರಿಸ್ಬೇಕಾ? ಉದಯದಿ ಅವ್ರದ್ದು ಕಾಸ್ಟ್ಲಿ ಸೆಲ್ಫಿ ಕೊಡಲ್ಲ ನಮಗೆ ಅವರು. ಶ್ರೀವಲ್ಲಿಗೆ ಒಬ್ಬರಿಗೆ ಕೊಡ್ತಾರೆ ಅವರು. ಫೋಟೋ అయినా ಲೈಫ್ అయినా ಶ್ರೀವಲ್ಲಿ ಜೊತೆನೇ. ಹೌದಾ ಉದಯ್? ಇಲ್ಲ, ಜಾಸ್ತಿ ಜನ ಶ್ರೀವಲ್ಲಿ ಇದ್ದಾರೆ, ಒಬ್ಬರೇ ಇಲ್ಲ. ಗ್ರೂಪ್ ಫ್ಯಾಮಿಲೀಸ್ ಫೋಟೋ, ಫ್ಯಾಮಿಲಿ ಪ್ಯಾಕ್ ಥರ. Consider a wire of length 4 meters and cross sectional area. Consider a wire of length 4 meters and cross sectional area 1 millimeter square. Carrying a current of 2 amperes. Carrying a current of 2 amperes. If each cubic meter of material contains, carrying a current of 2 amperes, if each cubic meter of material contains 10 power 29 free electrons, 10 power 29 free electrons, then find time taken by, then find average time taken, find average time taken by an electron to cross the length of the wire, to cross the length of the wire. Read that, read the question and then find the answer. I am asking the average time. టైమా వెరీ గుడ్ కరెక్ట్ ఉంది కరెక్ట్ అన్ఎక్స్పెక్టెడ్గా యాక్సిడెంటల్గా అలా వచ్చేస్తాయి కదా ఆన్సర్స్. My answer is 3.2 into 10 power 4. 3.2 approximately also you can get, there is no problem in that. 3 into 10 power 4 you can get approximately. Yes, you got that? Yes. 3.2 into 10 power 4 is the exact answer. Approximately also you can get the answer. Read the question slowly, then you can understand automatically answer you will get. Three point two into 10 power 4. Correct. How many of you got that? 3.2 into 10 power 4. Very less. Good, good, very good. See that, look at the question. See the question there. Consider a wire of how much length they are saying. Length is equals to 4 meters. L is equals to 4 meters. And cross sectional area 1 millimeter square. Area is equals to 1 millimeter square given. 1 millimeter square nothing but how much I can take? 10 power minus 6 meter square is the area. Then after that, carrying a current of, how much current is flowing in that? 2 amperes current is flowing. I is equals to 2 amperes. Then after that, if each, this line is very very important. I said yesterday already so many times that what is the difference between the capital N and then small n. Capital N nothing but what? Only number of electrons. Small n nothing but number of electrons per volume. Okay, in this they mentioned clearly that. So what they mentioned? If each cubic meter, nothing but volume they are mentioning. Cubic meter meaning is what? Volume only. If each cubic meter of material contains 10 power 29 electrons, nothing but 10 power 29 is a number divided by each cubic meter. Nothing but what value they have given? Small n. That is very important. If you might observe, if you might assume that as capital N means they have given each cubic meter, nothing but 1 meter cube is having how many free electrons? 10 power 29 electrons. So that my capital N value is 10 power 29 and then the volume is equals to how much? Nothing but 1 meter cube. So however how much you will get? 10 power 29, yes 29. However small n is equals to how much you will get? 10 power 29 only. So that you have to understand the terminology mainly. What terminology they have given in the problem is important. I said the difference also yesterday. So here each cubic meter of the material contains 10 power 29 free electrons. Then find the average time taken by the electron to cross the length of the wire. The telling about the average time taken, we don't have any formula for the time taken first of all. So you have to find out the velocity, with what velocity it is running in the conductor. This is the conductor of length L I have given. In that conductor of length L and then area A, then the electron is moving, it is undergoing in the number of collisions. So always you will get the average value only. Yesterday drift velocity formula also, left side equals to the left side what we are having, V1 plus V2 plus V3 and so on, Vn divided by n, that is equals to U1 plus U2 plus U3 and so on, Un divided by n plus A into tau 1 plus tau 2 plus tau n divided by n we are having. In that what we have made 0? U1 plus U2 I have taken as 0. Why? Because what is the reason? Average thermal energy becomes how much? 0. Average thermal velocity becomes 0. Next, average final velocity is becoming as what? Drift velocity. Average time intervals becoming as what? Tau, relaxation time tau. So that is what we got. Vd is equals to A into tau, and then A value already you know that minus E by m we have taken. So to use that formula, I don't have the electric field, nothing I have here. So that I have the current and then area is there. So that you have to immediately get in mind that, okay, I have to use this formula, that is I is equals to what is that? NEA into Vd. This Vd is there. Velocity nothing but what is the formula? Length by time, that's it. Finished. So that I is equals to NEA into L by T. From the yesterday's derivation only that is. So that T is equals to what I can take, average time taken, NEAL by I. That's the time taken. You will get the answer exactly as 3.2 into 10 power 4 seconds. That's the answer you will get. How many problems done? 4. Density problem finished. 1. Density integration 3 nena. ఓకేనా ఇప్పుడు టాబ్లెట్స్ తెచ్చుకున్నావా? ఎందుకు మరి తర్వాత ఎప్పుడురా? ఎక్కువైపోయిన తర్వాతనా? భోజనం అయిన తర్వాతనా? ఓఆర్ఎస్ అవి తెచ్చుకో. ఫైండ్ ద కరెంట్ ఫ్లో. Little tricky, that's it. Little tricky problem. Find the current flow through a copper wire of length 0.2 meters. Of length 0.2 meters. Area of cross section 1 millimeter square. Area of cross section 1 millimeter square. When connected to a battery of 4 volts. When connected to a battery of 4 volts. In bracket, electron mobility. What is the mobility means? What is the formula of mobility? Vd by E, drift velocity by electric field. Electron mobility is 4.5 into 10 power minus 6 meter square per voltage per second. Meter square per volt per second. How much I said? 4.5 into 10 power minus 6 meter square per volt and then second. Then charge of electron, already you know that, no need to write. Density of electrons in copper. Density of electrons in copper 8.5 into 10 power 28 per meter cube. 8.5 into 10 power 28 per meter cube. What is this value? What is that? What is the unit? You observe the unit. Unit will only give you the clarity. How much per meter cube? Nothing but what is that? Small n. Small n, right? Number of electrons per volume I have given there. So this is a small n value. Find out the answer now. Potential given, length given, and mobility given. Asking what? Current. Current you are saying, current is 1.224 amperes, correct? 10 power 3, correct. 1.224 is the correct answer. Try karo. Revise the formulas if you want. Turn the pages and then see which formula will be useful. At least try. .22 is the correct answer. Yes, 1.224 amperes. Exact answer is. One point two is the correct answer. Yes, you got that? Raise your hands. 1, 2, 3, 4, 5. Good. 6, 7. That's it. Girls, only 2 members. Good. What given in the problem, what you have to find, mainly you have to observe that. Yes? आया आंसर? नहीं आया? 1.228 कुछ नहीं होता, 1.2 आया ना बस. 1.2 if you got, then that's enough. See that you finally what you have to find out? Finally I have given it as you have to find out the current. Find the current through the copper wire of length whatever it might be. You have to find out the current. Current formula is what? I is equals to NEAVD. NEAVD. Now in that N is given, okay. Electron value we know that. Area given, but which we don't know. VD we don't know. We have to find out the VD. VD means they have given which one here? Mobility they have given. So that mobility formula is what? Mobility is equals to VD by E. Okay, I have the mobility. I want to find out the VD means I have to get to know the E value, right? I don't know the E, but voltage is given. So that E is equals to what I can write? dV by dx. Otherwise V by x. Voltage by length only. That is how you have to think about the problem. Simply I have to find out the current means you will write this formula and then you will stop here only. And you have to find out this means N we know, E we know, A we know, but VD we don't know. For VD what I have to do? Again I have to search for the problem again. What they have given? Useful components for the VD is what there? Mobility is there extra. Immediately you have to remember the mobility formula. What is the mobility formula? VD by E. Okay, then I got the VD. But again I have written the mobility formula, but I don't know again E value. For that again I have to search for the component in the question. Again voltage is there. Why? Because voltage is not useful here. But voltage is somehow it is useful to find out the electric field. Then electric field formula in terms of voltage is what? E is equals to V by L. That's it. Finished. Everything is finished. V by L I will get E, and then by that E I will substitute here. By this VD I will substitute here. Clear, right? That is how you have to think step by step. That's very important. Now here, whenever you substitute, first of all you have to find out the E value. E is equals to voltage is how much I have given? 4 volt. 4 volt divided by length of the conductor is how much? 0.2, nothing but 2 by 10 I will take. Directly 2 by 10. Then how much you will get here? 20. 20 Newton per Coulomb is the electric field here. E value we got. After getting the E value, I can find out the drift velocity. For that, mobility mu is equals to how much I have given as 4.5 into 10 power minus 6. Mobility, this formula I am taking here. 4.5 into 10 power minus 6, and then VD I have to find out, that divided by E value 20. Now whenever you send this here, VD is equals to 9 into 10 power minus 6. 10 power minus 5. It 20 coming here, no? Yeah. 10 power minus 5. VD is 10 power minus 5. Then 9 into 10 power minus 5. Now you substitute this VD value here. Then you will get the answer directly. The answer is approximately 1.2. Correct? Then that's it. Next we will discuss the resistance. We will start the resistance. So this terminology is important here. See that I have said two types of n values now. One is in the problem directly given. What is that? Each cubic meter is containing how many electrons here? 10 power 29. Nothing but which value they have given? Small n value. In this problem also, again they have not given it as small n. They have given us density. Density of electrons as this many per meter cube. This many electrons are there per meter cube means small n value is how much now? This 8.5 into 10 power 28. So n value you have to identify which is the n value there. That is very important. They have given per meter cube, otherwise they have given direct numbers, that and all you have to observe. If they have given direct numbers means you have to compulsory divide with volume. Then only you will get the correct answer. Clear? Next one is resistance. What is the resistance means? What resistance will do? It will oppose the current flow. That's it. It will oppose the current flow. Discussions later. So the resistance will do. What resistor will do? Nothing but it is a device that will opposes the current flow. In any metal. For any metal the resistance will be there. For example, if you take the pure metal, pure conductors means resistance will be how much? 0. Semiconductor means appreciable value will be there. Insulator nothing but how much will be there? Infinity will be there. And now we will discuss about that resistance, how that resistance will depends on the factors of the temperature, even by stretching, otherwise by folding, that and all we will see. Now first of all, resistance. What resistance you do? Resistance will do that, it will opposes the current flow, that is the resistance. Now this resistance, whenever I talk about the conductor, for example I am increasing the length, then what happens? You just think about the water flow only. I have taken a uniform pipe. If I increase the length of the pipe, then what happens? Resistance also increases, right? Why? Because the water will come slowly. Your water, whenever you take the smaller pipe which is connected to the motor, smaller pipe means don't consider that as a smaller area, small length I am saying about. Whenever I consider very small length, let me take 1 meter length connected to the motor. And then with what speed water will come out is different than the pipe which is connected 10 meters pipe is connected to the same motor. That speed will be different, this speed will be different. Why? Because their resistance is more as compared to this one. Viscous forces are acting more, right? As per it is going the length, then what happens? Viscosity also increases only. So here resistance, whenever I increase the length of the wire, then what happens? Nothing but resistance also increases. So clearly what I can write here, R is directly proportional to L. If I take longer wire at that time, resistance will be more. You understand? For example, for the longer distances, whenever you take the main lines, in that power wastage will be there, power loss will be there, because the distance is increasing there. Why? Because the distance as increases, then resistance also increases, so that R is directly proportional to L. Now whenever I increase the area, whenever I have taken this wire and then a bigger wire, what happens? Resistance. What happens whenever we are just taking the bigger area? For example, you people only, see, one by one is coming into the room, then what happens? Resistance will be normal only. Whenever all the people at a time you are coming, nothing but what happens? Resistance increases. Whenever I make it wider, then what happens? Resistance will decreases. So that here R is inversely proportional to area. The current is free to move here, so only the R is inversely proportional to area. Now together what I can write here, R is directly proportional to L by A. Now here a constant will take, that is a resistivity. Rho is not density, that is a resistivity. Rho L by A. In this chapter, wherever we get the density, there you are going to write small d. You can remember that. Wherever you get the diameter, there you are going to write capital D. And then resistivity indicates as what? Rho here. R is equals to rho L by A. This is known as the resistivity of the material. And this resistivity will depends only on the nature of the material. That's it. That is for the material like the spring constant. How the spring constant will depends on the material. In the same way, resistivity also depends on the material here. Now resistivity is independent of, this is also an important concept, resistivity is independent of dimensions of the wire, and then it is depends on what? Depends on material, nature of the material, nature of material. This is about the resistance. Basic resistance is R is directly proportional to length. Whenever I increase the length of the conductor, not increasing the length of the conductor, whenever you take the small conductor, at that time resistance will be less. Whenever you take the larger conductor, longer conductor, at that time resistance will be more. Whenever you take the smaller area conductor, at that time resistance is more. Whenever you take the wider area of conductor, then resistance will be less. So only R is inversely proportional to the area, and then R is directly proportional to the length. Together will become R is directly proportional to L by A. The constant is here rho, that is known as the resistivity of the material, and that resistivity of the material does not depends on the dimensions of the wire. It will depends only on the nature of the material. Clear? Now what are the units of resistance? Resistance units are ohms. Ohms, otherwise I can take it as ohm symbol, this one. Clear? And then resistivity will be what? See that rho is equals to R A by L. So R is nothing but what? Ohm. And then this one is meter square by meter. So that what I can write here clearly? Ohm meter. That is the resistance. This is the omega symbol we will use for the ohm. Clear? That is about the resistance. Copy everything. మనం ఇంకా కొందపా ಕಾಣಿಸ್ತಾ ಇದೆ ಸಿನಿಮಾ ಇಲ್ಲಿಂದ ಇಲ್ಲಿಂದ ಕಾಣಿಸಲ್ಲ Finished, huh? Write this clearly. Rho independent of dimensions. Rho is depends on the nature of the material. And also yesterday we have seen that drift velocity formula in terms of electric field. What is that? Vd is equals to what is the formula? A into tau. A value is how much? E by m. Clear? So from that we will get the resistivity we got already. We will get the conductivity also. Conductivity nothing but the reciprocal of resistivity is known as the conductivity. Now here whenever I take the I formula, Ray, what you got, Ray? ಅಲ್ಲಿ ಹೋಗಿ ತುಂಬ ಸುಮ್ಮನೆ ಚೇಂಜ್ ಮಾಡ್ಕೊಂಡು ಬಂದಿಯಾ? Right. Here I is equals to NEA VD. Now VD formula is what for us? NEA in terms of electric field. What is the formula of VD? E by m into tau. Yeah, minus it is there, we will take the magnitude only. Tau we will take directly. Then this one will be how much here? NE square AE by M into tau. Now this one I can write as NE square A tau by M into E. This is the I. I want to get the density. What is the current density? I by A. So that I by A is equals to what I can write now? NE square tau by M into E. This whatever is there, this one is known as a conductivity. Sigma is a conductivity. Rho is a resistivity. Sigma is a conductivity here. So here I by A is known as what here? J current density, and then that will be sigma into E. This sigma is known as a conductivity of the material. Conductivity of material, even that is also depends on the conductivity nature of the material only. Now this sigma is equals to what I can write now here? NE square tau by M. That is the value of sigma. That is the conductivity of the material. Clear? Just I have taken, nothing I have taken there. I is equals to NEA VD, and then VD formula I have taken. VD we are having, yesterday only I said that. VD can be asked in 3 types. One is by giving the current. What is that? By giving the current, what is the formula? I is equals to NEA VD. By giving the electric field, what is that? Minus EE by M into tau. What is the tau there? Relaxation time. What is the tau formula? Lambda by VRMS. Okay, that is a mean free path by RMS velocity. Okay, and also one more formula for the VD. What is that? Mobility. Mu is equals to VD by N. VD by E, I am sorry. In 3 cases the VD is possible, except that nothing will come. Okay, you have to substitute something in that, and then you have to get the answer finally. See that? Now I have taken resistance of wire of length L1, whose resistance is R1. Another wire of length L2, whose resistance you have to find out. What you have to take? Whose length you have to find out. I have taken 2 resistances R1 and then R2, and then length is L1. What about the L2? Different materials have, different wires I have taken. What you have to take? How the resistance is proportional to L? Directly proportional. So that what I can write directly? R is directly proportional to L, and then R1 by R2 is equals to L1 by L2. For example, in the wire only there is a small change in the length. Then how the resistance will vary? Small change in length is delta L, original length is L, how the resistance will vary I am saying. Percentage change in the resistance, otherwise fractional change in resistance. What I can write here? Delta R by R is equals to delta L by L directly will get. So that here delta R by R is equals to delta L by L. This is one possibility whenever the lengths of the wires are given, and also whenever the radius is R1 and then final radius is R2, how the resistance will vary? By the radius. R is what I said, R is inversely proportional to area, and then R1 by R2 is equals to what I can write? A2 by A1. For example, the second wire is having the radius R2 and then initial wire is having the radius R1. So that what I can write here? R2 square minus R2 square by R1 square. Otherwise R2 by R1 whole square I can take. R is inversely proportional to area, and then R1 by R2 equals to A2 by A1. A2 nothing but what? Pi R2 square divided by A1 is pi R1 square. Pi gets cancelled. R2 by R1 whole square we are getting here. And also, if there is a small change in the radius of the wire, then what will get here? Yes, very good. R is inversely proportional to area means inversely proportional to R square. Why? Because area is pi R square. Now delta R by R is equals to what will get here? Delta R by R is equals to 2 into delta R by R. And also here what happens whenever you are increasing the area, at that time what happens? Resistance decreases. So decreases, so only you get here minus. You don't confuse by the errors again. Errors will take always plus only. I am not talking about the error here. What is the percentage change in the R I am talking. And then already you know that by the theory itself, whenever the area increases, what happens? Resistance decreases. Now here also I am increasing the area. Nothing but radius I am increasing from R1 to R2. Then what will you get? Nothing but here minus 2 into delta R by R. Minus 2 into delta R by R we did not get from the formula. We got from the relation. As I increase the area, what happens? Resistance will decreases. That's it. Delta R by R is equals to minus 2 into delta R by R. Copy that. Copy the two cases. We will discuss the temperature dependency. These ratios are for the different wires of same resistivity. So whenever I taken the first wire of length L1 and then second wire of length L2, their resistance ratio will be there like this. First wire of radius R1 and then second wire of radius R2, their resistance ratio will be there like this. So that is about the different wires you have taken. Now whenever you are stretching at that time, otherwise you are folding, otherwise you are just rolling, whatever you do, then what happens? Nothing but volume will be constant. Based on that you will get different relations. Now here R is directly proportional to L is there, no? There R is directly proportional to L square will come. Otherwise R is inversely proportional to L will come. I said already in the solids chapter only, whenever you are asking about the ratios problems, at that time I said, whenever they said one thing is constant, nothing but in your formula that should be there. If they said volume is constant means, I said already in your formula volume should be there. Then by keeping that volume constant, you have to take the relation for the remaining components. The same thing also will be applicable here also. Clear? So we will do that. First of all, resistance depends on the temperature. The dependency of resistance on temperature. Dependency of resistance on the temperature. So here I have taken a wire of length L. Length L initially I have taken. Now what I am doing? Nothing but I am raising the temperature from T1 to T2. Then what happens to the length? You just forget about the resistance. What happens to the length? I am asking. Length will increases. How it will increases? Can you tell me the formula? L is equals to L0 into 1 plus alpha delta T. You know right already. Whenever you take the volumetric expansion, that time V is equals to V0 into 1 plus gamma delta T. What is gamma there? Coefficient of cubical expansion or volumetric expansion. This one is coefficient of linear expansion we will take. In the same way here we are taking that the length of the wire is L and then it is increasing by L1 to, let me take this is L0 and then increasing finally how much? L. In the same way L is equals to L0 into 1 plus alpha delta T. We know already the relation between the resistance and then length. What is that? R is directly proportional to L. So that R is directly proportional to L here. So wherever L is there, there I can write the R. Why? Because both are directly proportional to each other. Then R is equals to what I can write? R0 into 1 plus delta T. There alpha is known as the coefficient of linear expansion. Here this one is known as the coefficient of resistivity. Okay na, temperature coefficient of resistivity. So this is a temperature coefficient of resistivity. This is R is equals to R naught into 1 plus alpha delta T. I want to get the only alpha value. How to get that? R minus R naught is equals to R naught into delta T only. I am sending R naught inside here. R naught inside I send, and then R naught alpha plus alpha delta T, that is equals to R. Then R minus R naught is equals to how much will be remaining? R naught alpha delta T only. Then from that, this is what I can write. Final resistance minus initial resistance is delta R. So that delta R is equals to R naught alpha delta T. Then this one alpha is equals to what I can write? Alpha is equals to delta R by R naught into delta T. That is the alpha. Temperature coefficient of resistance or resistivity will take. So here already we know from the linear expansion concept, whenever I rise the temperature, then length of the conductor will increases. If I consider the initial length is L naught, and then finally length is becoming as how much? L, final length. I am not talking about the change, finally it is becoming as L. Then L is equals to L naught into 1 plus alpha delta T, where alpha is known as coefficient of linear expansion in that topic, particular topic. Now already we know the relation between the R and L. R is directly proportional to the length. So that what I can write here, in the place of L I can write the R. R is equals to R naught into 1 plus alpha delta T. Here R naught is the resistance of the material at temperature how much? 0 degrees. Initial temperature 0 degrees. And finally at temperature T, how much it is becoming? Nothing but R. So R is equals to R naught into 1 plus alpha delta T. Then I sent R naught inside and then taken the delta R here. From that alpha is equals to how much is coming? Delta R by R naught into delta T. This alpha is known as, in this particular chapter, temperature coefficient of resistivity. Clear? Write that. Any doubt, Pramod? Both are same only. That is about the material only, right? Phone. It's suffocating today. Open the windows, no? Bus. ನಮ್ಮ ಟೇಬಲ್ ಮೇಲೆ ಆಕಾಶದ ಐ ಥಿಂಕ್ ರೆಡ್ ಕಲರ್ ಅಟ್ಟ ಇರೋದು ಒಂದು ಬುಕ್ ಇರುತ್ತೆ, ತಗೊಂಡು. Clear? Write a problem. Alpha is temperature coefficient of resistance. Anything you can take, resistance or resistivity. There is no difference in that. That is just property of the material, how much it can bear the temperature. If alpha is more, nothing but it can bear more temperature. That is the main reason of the alpha. Yes. Write a problem. Like that, a wire has a resistance of 25 ohms, not 25, 2.5 ohms. Wire has resistance of 2.5 ohms at 100 degrees Celsius. At 100 degrees Celsius, the temperature coefficient of resistance of the material, temperature coefficient of resistance of the material, alpha is equals to 3.6 into 10 power minus 3 per Kelvin. 3.6 into 10 power minus 3 per Kelvin. Then find its resistance at 0 degrees. Find its resistance at 0 degrees. Find the answer. How much? 1.4. How much it is? No, check properly. How much? 3.4. Any other answers? 9. Whatever the answer you are getting, you have to get less than 2.5. The temperature at 100 degrees Celsius is, resistance at 100 degrees Celsius is 2.5, right? Then at 0 degrees Celsius, it should be less than that, obviously. That is the basic logic. 2.5 only. How much? Let me do that. Alpha given. There is no need to worry about the kelvins and all here. There is no need to worry about that. Then, what is the initial temperature? Initial or final? At what temperature I have given 2.5? 100 degrees Celsius. 2.5 at 100 degrees Celsius. That's important. Then you have to find out the 100 degrees Celsius. You have to find out the resistance at which degree Celsius? 0 degrees Celsius. Nothing but initial resistance you have to find out. R naught value you have to find out. So at 0 degrees Celsius. At 0 degrees Celsius, resistance is R, let us consider. Now, this is R we have considered, let me take that is R naught. Then at 0 degrees Celsius, R naught means what is our formula here? R minus R naught is equals to R naught into alpha into delta T. Otherwise, directly we can take this one. You want to find out R naught finally. So, for finding R naught here, R is equals to R naught into 1 plus alpha delta T. Then R naught is equals to simply what I can write? R by 1 plus alpha delta T. Now, R is equals to how much R value? 2.5, that divided by 1 plus alpha value is how much here? 3.6 into 10 power minus 3 into delta T is how much? Initially 0, finally is how much? 100 degrees Celsius, so that 100. Then 10 power minus 1. How much will get here finally answer? 2.5 by 1 plus 3 point, how much this is? 0.36. Yes, that's correct, 0.36. Then how much will you get here? 2.5 by 1.36. Then take it as 25 by 13.6. So approximately how much will you get here? 2 times, 13 2s are 26 only, right? Approximately 2 times nothing but you will get around 1.8 like that. The exact answer will be, I think 1.83 is the correct answer. 1.8 ohms. Simple logic, you might be get any answer. In the options also you can check. How you can check? Nothing but whenever you are raising the temperature, at that time what happening to the resistance? Whenever you are raising the temperature, resistance increasing. At 100 degrees Celsius they have given as 2.5 means at 0 degrees Celsius less than that or more than that? Less than that. So that less than that only you have to select. In the options directly you can select. If they have given all the options are more than that 2.5 and then one option is less than 2.5 means directly you can select the answer. You understand? That is basic logic only, basic sense only. So here R is equals to R naught into 1 plus alpha delta T is a formula for us. You have to find out the R naught. Initially first of all you have to decide which value they have given, which value I have to find out. They have given the resistance at 100 degrees Celsius. Few of the people might be mistaken that they have taken R naught itself as 2.5. Most of the people. Why? Because you did not read the question properly. You have to read the question properly. So R naught is nothing but the resistance at 0 degrees Celsius. I just mentioned while explaining only. R naught is nothing but resistance at the initial temperature 0 degrees Celsius. And then at finally at temperature T, what is the temperature, what is the resistance? Nothing but R is the resistance here. So R is R0 into 1 plus alpha delta T. From that I have to find out the R0 value. R0 is equals to R by 1 plus alpha delta T. Just I have substituted everything. Don't worry about the units there. Alpha might be given in the per degree Celsius or per Kelvin. Everything is same only. Why? Because the temperature difference is same only for the Kelvin and then what is that Celsius. Understand? How many temperature difference will be there? From the melting, from the freezing point to boiling point, 100 only. The difference of the temperature is 100 only. It will start from 0 to 100. That will start from 273 to 373. That's it. The temperature difference is same. Everything is same only. Per Kelvin, per degree Celsius, everything is same. Per Fahrenheit, they will not give. Clear? That is about that. Next, next problem. Two resistors having resistances R1 and R2. Two resistors having resistances R1 and R2 at 0 degrees Celsius are connected in series. Then what is the condition? For effective resistance in series? Effective resistance in series is same for all the temperatures. Purely logic based question this one is. You have to understand the question mainly. The effective resistance in series is same at all the temperature. The last line is very important. See that. I'll do. So two resistors having the resistances how much? Initially at 0 degrees Celsius, R1 and R2. Listen properly, this is important. The same thing you will get in the again thermal expansion also. There L1 alpha 1 is equals to L2 alpha 2. One condition will be there, very important problem that came in the previous NEET also. The same way here also the same concept only, but the thing is you have to understand at what temperatures they are asking. First one is the two resistors having the resistances how much? R1 and R2 at what temperature? 0 degrees Celsius. At 0 degrees Celsius, R1 and R2 are the temperatures. After that, are the connected in series. They have connected in series, nothing but what is the series combination of resistors? R1 plus R2. Okay, finished. R1 plus R2. Next, come to the next line. Then what is the condition for the resistances in series is same at all the temperature. The effective resistance should be same at all temperatures. Let me take at some temperature, let me take T degrees Celsius. At T degrees Celsius, my resistances are R1 dash and then R2 dash. They are also connected in series. What is the series value you will get here? R1 dash plus R2 dash. At what temperature? At T degrees Celsius. Then see that question. What is the condition for effective resistance in series is same at all temperatures? Nothing but initially at what temperature we were having? 0 degrees Celsius, series connection is there. Finally at what temperature we are having? T degrees Celsius, how much that is? R1 dash plus R2 dash. Both should be same. What will be the condition for that? That is what you have to find out. So here R1 plus R2 at 0 degrees Celsius should be is equals to R1 dash plus R2 dash at T degrees Celsius at any temperature. They said at all temperature means first of all you consider only one temperature. Then you show them equally and then you get the condition there. So initially at 0 degrees Celsius I have taken the resistors as R1 and R2 connected in series. Finally at some temperature T, R1 dash and then R2 dash are also connected in series. And then in the question they are saying that both should have same values. This effective resistance should be is equals to this effective resistance. What is the condition for effective resistance of this combination should be like same first one for all the temperature. That is the question they have asked. Now R1 plus R2. R1 is at what temperature here I said? 0 degrees Celsius. So that R1 plus R2 it is at 0 degrees Celsius directly. There is no rise in the, there is no change in the resistor and all. Now From where to where we are changing? 0 to T degree Celsius. Then R1 is changing from where to where? R1 to R1 dash, and then R2 is changing from R2 to R2 dash. Now tell me R1 dash value. R1 dash is equals to how much? R1 into 1 plus alpha into delta T, correct? So that R1 into 1 plus alpha 1 into delta T is at what temperature? T degree Celsius. Then next second one, then R2 into 1 plus alpha 2 into delta T, that is again T only. Why? Because T minus 0, T minus 0 only. Clear, you understand? These are the resistances after rising the temperature from where to where? 0 to T degree Celsius. So only I have taken R1 dash as R1 into 1 plus alpha 1 delta T, and then R2 into 1 plus alpha 2 into delta T. Then from this, R1 plus R2 is equals to R1 plus R1 alpha 1 T plus R2 plus R2 alpha 2 T I can take. Then what will get cancelled here? R1 R2 gets cancelled. Then I can take it as R1 alpha 1 T is equals to minus R2 alpha 2 T. Then T gets cancelled here. Then clearly what I can write here? R1 alpha 1 is equals to minus R2 alpha 2. In the thermal expansion also, you will get L1 alpha 1 is equals to L2 alpha 2. Same condition only you will get again. There also they will be joining two rods in series, and then you will get the final answer. Clear? Listen again. Listen properly. One more kind of problem will be possible in this case only. I will tell that one also. Now here they have given two resistors first of all at 0 degree Celsius. What is the resistors values? R1 and then R2 at 0 degree Celsius. Now what they are doing, nothing but they are saying that what is the condition for the effective resistance should be same as the first effective resistance. Final effective resistance should be same as the first effective resistance at all temperature. Why to take at all temperature? I will take at one temperature only, any one temperature. So at any one temperature if I take, the effective resistance is how much here? R effective is equals to R1 plus R2 at what temperature? 0 degree Celsius. And then here R effective at what temperature? At T degree Celsius. Combination, series combination only. Now R1 plus R2 at 0 degree Celsius, R1 dash plus R2 dash at the T degree Celsius. Now in the question itself they said the same as initial effective resistance. Same nothing but you have to equate both. So R1 plus R2 is equals to R1 dash plus R2 dash. This R1 is the resistance of the first one only after rising the temperature. Resistance of second one after rising the temperature. From where to where you are rising? 0 to T degree Celsius. Now after rising the temperature, you know the final resistance value. R1 dash is equals to what I can write from this? R1 is equals to R0 into 1 plus alpha delta T. In the same way, initial resistance is how much here? R1. Finally it is becoming as how much? R1 dash. So that R1 dash is equals to R1 into 1 plus alpha 1 into temperature difference is how much here? T minus 0. So that how much you will get? T only. Plus second one again R2 dash is equals to R2 into 1 plus alpha 2 into rise in temperature is again T minus 0 only. Then I have sent inside and then I cancelled everything. We got R1 alpha 1 is equals to minus R2 alpha 2. Very, very important. Copy that. Underline that in question. Effective resistance is same at all temperature. Then next write a problem. Two wires. Have you written this one? What is R1 dash here? What is R1 dash here? The resistance of the first wire at what temperature? T1 temperature you will get, clear? And then R2 is the effective resistance of the second wire after rising the temperature T degree Celsius. Then write that. Next one. Two wires of temperature coefficients alpha 1 and alpha 2. Two wires of temperature coefficients alpha 1 and alpha 2 and resistances R1 and R2, R1 and R2 are connected. Then find the effective resistance. In that first question for series combination. Next question, parallel combination. Series and parallel combinations you have to find out. What is alpha effective in series? Alpha effective in parallel. Off video off